Before the invention of writing, a spoken word lasted only as long as the vibrations in the air. Oral languages leave no fossils. They dissipate entirely, which makes tracing their deep prehistoric origins a difficult problem for anthropologists. This map shows the current scale of the Indo-European language family. Of differences in vocabulary and grammar, linguists know these languages share a single prehistoric root, a mother tongue known as Proto-Indo-European. The challenge is pinpointing when and where that ancestral language was first spoken. In 2016, anthropologists led by Jamshid Tehrani published a study in the journal Royal Society Open Science that bypassed the lack of physical text by using an unconventional methodology. They used computational phylogenetics. This is a mathematical modeling system traditionally used by evolutionary biologists to map how DNA mutates as species diverge from a common ancestor. But the researchers didn't apply this algorithm to genetics. They applied it to folktales, specifically the thousands of oral traditions cataloged in the Arney-Thompson-Uther Tale Index. Oral stories act similarly to genes. As they are passed down through generations, their specific local details mutate. The animals change, the locations shift, but the core skeletal structure of the narrative survives. By tracking the mutation of specific fairy tales backward along the language tree, anthropologists identified continuous, unbroken story structures that appear to be up to 6,000 years old. These ancient oral traditions act as a form of cultural fossil. They reflect the broad era when our ancestors transitioned into Bronze Age technology, providing a timeline for how human societies adapted to the introduction of metal and portable wealth. The researchers started with a dataset of 2,000 tales of magic categorized within the global ATU index. This map illustrates their first filter. By removing narratives isolated to other continents, they narrowed those 2,000 stories down to a subset of 275 tales shared specifically across Eurasia. Populations often share stories simply by trading. To solve this, researchers plotted linguistic similarity against geographic proximity, isolating stories passed down through direct inheritance. The output leaves 76 verified tales, predicted exclusively by language ties. Pushing deeper into the phylogenetic tree, they found 50 of those 76 tales track back to the last common ancestor of the major Indo-European subfamilies. Out of the thousands of global stories analyzed, the modeling identifies only one single tale that traces all the way back to the absolute Proto-Indo-European root. Cataloged as ATU 330, The Smith and the Devil, this singular narrative provides a window into the technical vocabulary and social concerns of early Proto-Indo-Europeans. This historical illustration captures the core plot of ATU 330. A blacksmith strikes a pact with a malevolent entity, gaining the power to weld materials together. He then uses that power to trap the entity and escape his side of the bargain. The Christian devil is a relatively recent cultural addition. In the original version of this story, the antagonist was a generic malevolent spirit, a jinn, or a physical personification of death. This chart shows the structural equation: a blacksmith, a malevolent entity, welding, and entrapment. Highlighting the blacksmith and welding nodes reveals the narrative's dependency on the physical existence and cultural understanding of complex metallurgy. This technical requirement intersects with an archaeological debate over where the Indo-European language family began, the Anatolian hypothesis versus the Kurgan hypothesis. The Anatolian hypothesis argues that Proto-Indo-European originated roughly 8,000 years ago, spoken by early Neolithic farmers who built the stone structures seen here in Turkey. ATU 330 exposes a flaw in that timeline. Complex metallurgy, professional blacksmiths, and the concept of welding did not exist in the Neolithic era. Early farmers could not construct a narrative around a technology they hadn't invented. Compare that to the Kurgan hypothesis, which argues the root language emerged 6,000 years ago among pastoral nomads of the vast Pontic Caspian steppe. The Kurgan timeline matches the Bronze Age development of the forge. The 6,000-year-old origin point calculated for ATU 330 aligns with the archaeological record of early metalworking. These ancient metal objects demonstrate what early smiths were producing. They were crafting durable items like spearheads and sickles. Witnessing metallurgy for the first time was profound. Melting solid rock into liquid fire, then cooling it into a weapon appeared as literal magic. ATU 330 shows a society processing this technological leap. They framed it as a Faustian bargain. The mastery over nature was so significant that it must require a dangerous pact with a supernatural force. By proving Proto-Indo-European speakers possessed advanced metallurgy, ATU 330 provides narrative evidence supporting the Kurgan hypothesis, placing the language's origin in the early Bronze Age. If we move the phylogenetic timeline forward by roughly 1,000 years, the algorithm isolates a second major story, ATU 328. Modern audiences know ATU 328 as Jack and the Beanstalk, or classically as The Boy Steals the Ogre's Treasure. The core function of this story is specific. It relies on the targeted theft of a concentrated hoard of portable treasure from a powerful figure. This collection of artifacts represents a shift in how humans interacted with wealth. As the Bronze Age progressed, metallurgy moved beyond survival tools into the creation of high-value, portable goods. Gold torques and refined metals introduced the concept of extreme capital accumulation. For the first time, wealth could be concentrated and moved, shifting the social focus away from the shared output of subsistence farming. These trade routes were established specifically to move lightweight, high-value capital, amber, cut gems, and gold, across vast geographic distances. ATU 328 acts as a psychological adaptation to this new economy. It is a narrative processing the realities of social stratification and the vulnerability of concentrated wealth. The contrast between the two tales is direct. ATU 330 is a story about the danger of a process, the physical act of forging technology. ATU 328 is a story about the danger of an asset, the accumulation of capital. Together, they show our ancestors organizing their moral frameworks to survive an increasingly unequal, trade-driven world. The early Bronze Age followed a clear progression. The technical development of the forge was followed by the economic reality of the hoard. This timeline maps the language tree directly against archaeological dates of Bronze Age advancements. The data nodes for ATU 330 and 328 align with these technological milestones, functioning as cognitive tools for early humans to process their new technical and economic capabilities. Computational phylogenetics allows us to measure these transitions with mathematical precision. By treating oral traditions like biological phenotypes, researchers can bypass the need for written text. We can extract historical data directly from the structures of our oldest stories. Modern iterations like Faust or Jack and the Beanstalk still circulate today because they reflect the same fundamental human anxieties about technology and wealth. These fairy tales preserve a specific sequence of human development. They track how our ancestors began to conceptualize, fear, and eventually organize the power granted by their own inventions.